Welcome. In this lecture in linear data analysis, which has multiple sessions, we'll explore how we can adapt principal components analysis, or PCA, to analyze data that have labels. The main concepts for this lecture are: what does PCA do when we explore it on the means of the labeled data? How does PCA and the Rayleigh quotient help us to solve this problem? What is linear discriminant analysis, and we'll view it as a form of optimization. And then we'll apply this to some of Fisher's iris data. One problem we can think of as we go through this lecture is: how can we separate data that have labels? Let's explore this in a little more detail. So PCA, or principal components analysis, explains. It doesn't predict. That is, it treats all of the data as though they're independent variables and doesn't attempt to provide new categories for new data. The scores are what we use to reduce the number of variables. For example, we might go from a very large number of variables down to only 2 for visualization. This dimensionality reduction is really useful, both to help us understand our data and to perform other actions such as clustering. Indeed, clustering often works better after principal components analysis than it does on the original high-dimensional data set. Now, a question is, what happens to labels when we do all of this work? Labels will help us to partition the data. Does this help, or is this a hindrance? What is happening when we deal with these data that have labels? And we'll try exploring this with a new data set.